Triangles. Hello, inquisitive minds. Today we'll talk about triangles. The triangle is the simplest shape that we can make, a shape with three sides. 1, 2, 3. That's about as simple as a polygon or a shape with straight sides can get. There are many kinds of triangles. You can look those up elsewhere in the internet. But in this session, let's focus on this kind of triangle, called the right triangle. This triangle is called a right triangle because one of the interior angles is 90 degrees, or a right angle. The right triangle is special because it has many uses. Let's talk first about the parts of a right triangle. If we rest the triangle on one of its shorter sides, we have the base, the height, and the longest side, which is always called the hypotenuse. Again, hypotenuse, the longest side of a triangle. It's a big word, but let's remember that because the hypotenuse will be useful for many things. Also, if we look at this picture a bit more, we will notice that it is the two shorter sides that are always at right angles with each other. The longest side, or hypotenuse, will never be at right angles with another side. Now we can get the area of a right triangle if we know the length of its base and its height. In this example, the area of a right triangle is half the area of the rectangle. So in formula, the area of the right triangle is 1/2 of the base times the height. Again, that's 1/2 the base times the height. This illustration also shows why the right triangle is half the area of the rectangle, with the hypotenuse slicing the rectangle in half. We can also see that the inverted and upright triangles are the same in area. If the base is 3 and the height is 4, then the area of the triangle is half of 3 times 4, or half of 12, or the area of the triangle is 6. Now what about a triangle that does not have any right angles? How do we find the area? First, we rotate this triangle so that it's sitting on its hypotenuse. A line perpendicular or at 90 degrees to the hypotenuse running up to the highest point of the triangle will be its height. The hypotenuse will be the base and the perpendicular line will be its height. Once we do that, we can use the same formula, that is, the area is equal to half of the base times the height. If we look at this image, we can see how the formula works with the triangle equal to half of the area of the rectangle. And here's another image that proves that the same formula works with the triangle being equal to half of the area of the rectangle. These mathematicians are really smart, right? Not only that, we can get the area of any polygon using triangles. First, we cut up the polygon into triangles and find the heights using the same method that we used a while ago. And we just add up all the areas using the same formula, in this case, the area of 5 triangles. We can also roughly define any form in 2D or 3D using triangles, as this image will show, or this one, but we can spot some non-triangles in this pic. Now, why is a triangle better than a diamond or a rectangle in defining 3D surfaces? Because a triangle is a flat 2D shape which we can use to define 3D volumes. If a diamond is bent, it is actually 2 triangles. The other use of the right triangle is to be the foundation of the Pythagorean theorem. There's another video for the Pythagorean theorem. Please see the link in the description below. In addition, the right triangle is the basis for trigonometry, which itself opens the doors to periodic functions, navigation, mechanics, which to the rest of us is just higher math. But for now, let's just understand that trigonometry is simply the relationship of one interior angle of a triangle to its 2 other sides. We use another set of terms for the sides of a triangle in trigonometry, just so we can establish the relationship of 2 sides to an angle inside the shape. As an example, the sine of this angle is equal to the length of the opposite side divided by the hypotenuse. These are the basic functions of trigonometry. But enough of that. One cool thing about triangles is that the interior angles will always be equal to 180 degrees. This image shows why this is so. The interior angles of the triangle, when put together, total 180 degrees. Now, before someone catches us watching an educational video, the triangle has some nifty uses. If we want something to stand, we need to find at least 3 points on the ground, and that's a triangle. Well, no, that's not 2 points. Human beings stand on 2 heels and 2 balls of our feet, so that's 4 points. Well, okay, that's almost 1 point, but not many people can hold that position for long. In addition, the triangle is also the foundation for structural frames, such as trusses. The triangle converts distributed load mostly into 2 axial forces, tension and compression. No, not that kind of tension, this kind of tension, and this is compression. The truss redistributes loads so that the loads at the top of the truss gets transmitted down to the bottom of the truss, which are useful for many uses, such as roofs, towers, and bridges. In engineering, a truss is considered a 2D shape. If we apply triangles in 3D, we call that a space frame. So again, a truss is 2D and a space frame is 3D. And both the truss and the space frame use the triangle as its structural shape. And with the space frame, we can make a structure in all shapes and forms, like this one and this one. In art, the triangle is used to create a strong composition. It's so basic a shape that there is a base, a hierarchy, and a peak, and it just looks good. Some examples of triangular composition are this, no, not this, now that's better. Now how about pyramids? Does a pyramid really keep razor blades sharp or keep meat fresh? Well, sorry, I can't help you there. In my science project back in high school, the meat got stinky after a few days. Thank you, and please don't forget to comment, like, and subscribe.